This video will acquaint you with the digital multimeter and a solderless breadboard for making electronic circuits. Alligator clips can help you make connections to the multimeter. Here we're demonstrating the measurement of the resistance of this particular resistor. After attaching the leads, turn the dial to the ohms positions on the lower left. Turn the dials until you get the most significant figures in the readout. Here the reading is 3,250 ohms. The box contains a power supply providing plus and minus 12 volts, or a set of batteries which provide plus and minus 9 volts. The breadboard contains a matrix of holes to make connections to resistors and other components that we can plug into these connectors. The row of 5 holes running perpendicular to the length of the board are connected to each other and nothing else. The other holes along the same line are separated by a valley between them and the first column. Other sets of 5 along lines parallel to these columns are in electrical contact with each other, but not in contact with their neighbors. Along each edge, 2 rows of holes extend the length of the board. All of these holes are in contact with each other up to the place where they are separated by a wider gap. The holes along the line on the other side of this gap are independent. Likewise, the holes in the second row are electrically connected but independent of their neighbors in the parallel row. At the beginning of your work, connect a wire to each of the 3 binding posts on the left side of the box. These posts are connected to the power supply inside the box. The black post is connected to ground or 0 volts. The voltage between the black post and the upper red post is nominally plus 12 volts. The other post provides nominally minus 12 volts. Connect each of these 3 wires separately to one of the rows extending lengthwise along the board. In doing so, we now have many places along the board which we can connect to the ground, plus 12 or minus 12 volts. We can use a wire to extend the grounding strip and the power supply voltages along the entire breadboard. Since we will usually measure voltages on our board with respect to the ground, it is handy to plug a wire into the row for the ground and connect a black lead, in this case, to the common side of our voltmeter. Now we can quickly test the voltage at other points in our circuit using the other lead. Here we demonstrate the creation of a simple voltage divider using 2 fixed resistors. One resistor connects to the ground and a column 5 holes in the center of the board. The other resistor connects to the same column of 5 and bridges across the groove in the center to a separate column of 5 holes on the other side of the board. Another wire is used to jump from the plus 12 volt supply to connect to the row with the second resistor. We can monitor the voltage at the center of the 2 resistors by just clipping on to one of the bare wires of the resistors. We also can check the voltage at the far end of the resistor and see that it's the same as the positive supply or the ground at the far low end. Alternatively, it may be convenient to connect a wire to the junction of the 2 resistors and take the voltage out somewhere else on the board. We can use one of the two built-in variable resistors in order to provide a selectable voltage over a wide range. Above the knob used to adjust the setting for the resistor are 3 holes. These holes have electrical contacts to connect us to the slide wire on the resistor, as well as the 2 extreme ends of the same resistor. Here, pin 3 is connected to ground, and pin 1 is connected to the negative power supply. Connecting pin 2 in the center to a convenient column on the board allows us to monitor the voltage as we rotate the control. As we rotate the control to the left, the slide wire moves to positions closer to -12, or in the other direction, closer to 0. Another feature on the board is a pair of switches. Beneath the board are 3 electrical contacts. The position of the control gives us a connection between pin 2 in the center and one of the pins on either end. Finally, the design of the board allows us to make independent and convenient contact to each pin of an integrated circuit chip. Demonstrated here is a simple circuit using an operational amplifier and 2 fixed resistors. Always turn the power off before making any connections to the op amp. Be sure to connect pin 7 to the positive supply and pin 4 to the negative supply before turning on the power. Otherwise, you can burn out the amplifier.